Buddy, are we live? I gotta do my check. Is it working? Okay, it's working. Hello everyone. Welcome. Let's make our official announcement. Do a little Discordy. Do a little red circle. We are live at twitch.tv/lens_r. More easily said as Lenser. More compiler. How about that? The transformation is happening. Alright, again, it's wide. I don't know why it's wide, but we like them thick, so yay. It'll be good for us. Let's get right started. Obviously, by the announcement that you just saw me write, we are going to work on the compiler. So let's think about what we would like to do. And that's right. Oh. You know, the well-timed yawn. That's right. I found some resources yesterday. I actually found the GNU binutils documentation, and within that, the GNU as documentation, which was surprisingly hard to find. RPWH says, yeehaw! RPWH, you're the first one here. How's it going? Our #1 supporter. Let's think about this. So I gotta... It opened in the wrong browser. I just gotta back it up. There we go. Woo! So I finally, I'll put this in the chat if anyone wants to look at this. RPWH says, I'm doing good. Not sure if I need to redo some of my solder, lol. Hopefully not, but it's a possibility. Redoing solder is not uncommon in the world of hobby electronics. It's almost all of hobby electronics, actually. That's all you do. You just put some parts in a different order, and then you go, oh yeah, that'll work, and then you resolder it. For those of you that don't know, RPWH is building a Lily 58 keyboard. And he got halfway through, maybe all the way through now, but it's beautiful. And he just built this keyboard yesterday, which is incredible. It's so beautiful. I like the Lily 58 though. I'm really excited to see it. In any case, that's a great plug. Join the Discord down below. It's in the About section. If anybody's here. Probably in the VOD, but whatever. It all works, baby. There's descriptions everywhere. So with this using as for the actually GNU binutils, like the newest version, we can actually see modern documentation, because all the documentation, when you Google like GNU as, for some reason, okay, of course now it comes right up. For some reason, all I get is this, not even this, I get old GNU. Yeah, see? So you get old GNU, which is it's not ideal because there's no new things. So all these CFI directives, bundle directives, all of these directives just don't exist. And this is what I was getting linked because I Googled it and clicked that one. Isn't that amazing? How amazing is that? So I actually found the proper documentation on Sourceware of all places. But it's here and it's new and it has everything we need. So CFI directives, if you don't know, CFI stands for call frame information, I believe. Based on this Stack Overflow thread. That's hard to say, Stack Overflow thread. Okay. So there's this question, what do CFI directives mean? Because if you look at disassembled code that GCC generates, it's got lots of these directives all just kind of mushed in there, and it's like, what is all this? That's just instructions, but it's really, it's confusing, right? There's all these directives, and it's kind of confusing how many labels there are, and right? It's a little bit odd. But once you start to understand what CFI means, CFI stands for call frame information. I believe that's answered down here by Lindy Dancer. Perfect. Call frame information. CFA stands for call frame address, which is the address, the stack pointer location of the caller function. So but during a call instruction, a call effectively pushes the current base pointer and then jumps to this address. And this address just happens to be up here, if that makes sense. So when it jumps to this address, what's on the stack is the base pointer, and then we push the return address of the function. Sorry, I can confuse myself all day. So it pushes the return address of the function, which is just this instruction, right? The memory address of this instruction. So that gets pushed onto the stack, and then it jumps to this, in which case we push the base pointer right after we start a process in the call frame information. So then we can say, okay, our CFA offset, which is our call frame address, right? That is 16 off of our current base pointer after this instruction. Does that make any sense? And then we can, I don't know what all this register stuff is. We'll have to look into what this number means. But the 16 makes sense to me. And also, then you just say CFI endproc, and that allows at least some debugging information to happen. And eventually, if we get all these numbers sorted out in the middle, we could even have debug information and stack unwinding. So we could have a debugger that hooks in, like GDB could just work with our programs, which would be pretty sweet. So this is something we're gonna at least look into a little bit, and yeah, we have to look into what CFI register means. So it just says previous value of 1 is stored in 2. Okay, and it says define CFA. Defines a rule for computing CFA as take address from register and add offset to it. So from register 6, I'm not sure how we get this internal number. Hopefully there's a, you know what I mean? Like which register 6 doesn't exist in x86-64. Are they talking about the stack pointer and the base pointer? Which order are they in? That's something I'm a little worried about, because CFI offset is not really. So it just says previous value of register, but it doesn't say what form it's in. I don't know, we'll see. But this is all debugging information that will allow for stack unwinding, which is very exciting and something that I would love to look into. I also have Godbolt here, and you can actually look at the disassembled code for this little code snippet, which allows, there's a lot of debug information, and you can see that we have a lot to figure out. But for now, I say we start just putting in start proc and end proc. And then you can also see that location. So this .lock, I'm assuming stands for location, within the previous file that you said, right? So in this file is where this function is. And it's at this location. Then you start the process, you push your base pointer, you tell it your offset, somehow figure out what register 6 means. Hopefully we can just always use register 6 because it's base pointer or stack pointer or one of those. Not really sure. We'll figure it out. In any case, we can now see that the location, so a debugger could use this file and location to actually, you can see on the left, it's actually highlighting the proper line of the function declaration, which is pretty dope if you look at that. That's it doesn't always do it. There it goes, it does it there. That's very sweet. And so this location allows a lot of debugging information. Then you can say the size of the function. I'm not sure why we need the size of a function and why that's like important. Like, oh, this is how big the function is. But I guess it's useful for debugging. So we may think about doing things like this as well, with function begin and end labels on top of the labels that we use to jump to. This is why debug programs are not as efficient, by the way, in case you didn't know. All this stuff. And also the fact that they're not optimized, but, you know, that can be said for any program. VMe says, huzzah! Back from the dead. It's VMe. How's it going with the premium mushroom emotes? Ooh, those are beautiful. We were just looking at some debug documentation and some debug directives that we're gonna have to start thinking about so that we can have programs that are debuggable. And yeah, I figured that would be fun, but that's not what we're gonna work on right away. First, we have some things to fix from yesterday, if I remember correctly. So let's try and set up a little build command. VMe says, it's alive. It's so good to see you, VMe. How's it going? Thank you for tuning in. We got two donators in the house. This is amazing. This is the first time ever, I'm pretty sure. Thank you so much to both of you for the support. I really, really appreciate it. It's why I'm still doing this. Or why I can still do this. Negvorsa says, hi. Did I miss any code 5? No, you didn't miss any code 5. We're just writing our build command now. Oh, Negvorsa. VMe says, it's so good to finally catch you live. With a bunch of Craigasms. Yee. That's awesome. I'm glad it's exciting. That gets me excited. I'm excited, chat. Okay, and we're just gonna feed it like an example. So we're trying to get the downwards function argument problem, and we're having an issue in CodeGen. So let's start there. But VMe, I'm so glad that you were able to catch me as well. We are finally, the stars have aligned for us. I don't know why there was 2 lines there. That was kind of bothering me. In any case, where are we at? So during CodeGen, could not get local base pointer offset of variable. VMe says, that juicy code. That's right. That's right. The switch case of a lifetime. This is like the main CodeGen though. This is CodeGen expression, so it's gonna be heavy. It's a heavy hitter. We could put all these into functions and make the switch case simple, but I don't think that's necessary. For now, we just get it done. Okay, so it looks like a variable access is the problem. But it may be because when we call a function, I think the problem is that, yeah. So the problem is that when we call a function, I don't think we're pushing the proper arguments. Or at least, I don't know. It doesn't seem like we are. Or should we be setting them in the environment, in the CodeGen context? Is that what we should be doing? So let's think about this. Push arguments in reverse order. What are we having? This is not an argument that we're dealing with. We're dealing with after so we're generating the function itself, not a function call. That's why I'm a little bit confused. Oh, functino, always. Oh my god. Oh my god. I can't type. It's on the screen. Okay. VMe says compartmentalization? Nah, it's for the weak. VMe, it's so good to have you. Oh, that's so funny. Good design patterns? That's disgusting. Only weak programmers use the crutch of a good design pattern. Real Giga Chad programmers. That's when you just write the most spaghetti code, but it works perfectly, and you're like, see, I'm perfect. That's the Giga Chad brain. I get it. I see it. Just that sweet, sweet, you know? Nick says, I just came home from school. I'm sorry to have, that you had to get through that. You might like school, so hopefully you had a great day. If you didn't, though, I'm sorry you had to get through that. It is a good morning for me. Hopefully it is a good afternoon for most of you. RPWH says, apes together strong. Ooh, ooh. That's right. With the orc emote that I've never seen before. That's amazing. The lens script motto. That's a good motto. Apes together strong. Oh, that's so good. So, it seems like also, I wonder if it'd be easy as this. I'm just gonna sneak this in here and see if anything breaks. We're gonna try it. Still could not get local base offset. So we say parameter is function children children. Is that true? I don't think that's true. So when we have a function, the parameters are the children of the second child. So it would be next child children would be the parameter. Hey, look, that was it. Hey, thank you. That'll be $300. No, not really. We did it. Also, there's a print node somewhere that we have left in, and I'm scared that I may have committed it. We gotta figure this out. Also, we gotta not print out every time we do type not found, because that's how we parse things now. It's fine. Everything's fine. Well, we fixed it. That's pretty dope. Yeah, it works again. Remember, this is a clean first from CMake, so we literally build every single C file from scratch every time, link it all together into an executable, and then compile our little downwards funarg example, which we should take a look at. Let's take a look at our example. Ooh, first we gotta load our little un mode. Again, on me for not putting this in my Lisp auto load, but whatever. Hey, look, function names are now not highlighted. It's gonna be some complicated regex. There's gonna be a lot of grouping trying to get the function name. In any case, we broke all of our previous code. So now all this code, yeah, it don't work no more. Also, that's an interesting bug. There must be white space for it to be a keyword. We gotta fix our Emacs mode a little bit as well. But it's a perfect timing because this code no longer works. This is defun has been removed, it's no longer a keyword, and to define a function, we now use this syntax. And you may be saying, it's terrible, you duplicate the function signature, you're a monster. And I would agree with you. Vimi says defun, no. Here's the thing, it's gonna come back, it's gonna come back. Vimi says RIP defun. RIP, Hail Mary, say your graces. I don't know the actual words to say, but you know, something like that. Praise the Lord. How did I just type that? Wait, chat. What did I press? What is this? Okay, we're getting a small tangent. What is this? Control P, displayed as Control P. Code point 16. It's hex 20? What? So I press to input control. Did I really press this? Did I really press Control X8 return 10? I don't think I pressed Control X8 return 10. If I did, that's crazy. I don't know how I typed this, chat. Vimy says, "The Volt." First time chat from a new viewer, Snarlferb. I swear I had that happen before. Control C. Oh man, in terminals it happens all the time. It's like, oh god, no, let me out. I don't even know how I did that. So, yeah. So it's not like Control X8, Control P. Because Control X8 is like enter, insert char. See, Control H is paging and help. So we have next page, previous page. Digit argument. So it's crazy. I really don't know how I did that. In any case, this is how we define functions. And the reason that we have to repeat the function signature is we do it one time for the variable declaration. Because now, my integer returning function, also we really have to change some things. But it's fine. Vimy says, how do you exit Vim? Me, for example, I just restart my PC. Wait, this is gonna be great. Are you ready? Are you ready? Oh no. Oh no. It's happened. What do I do? Chat, help. Oh no. No. Oh no. Chat. Does anybody know? How could I get out of this water closet? Fast. Oh no, it didn't work. We just need to quit fast because there's no file name. We're not editing a file. I did it. Chat, look. Am I a programmer now? Do I get like a salute when I walk by? Oh, programmer, chat programmer. He gets out of Vim. RPWH says press the exit Vim button on the top of your PC case. Lamau. Vimy says you tickle my Vimness in all the right places. Ooh. I don't know if I should now. I feel naughty. Oh, you guys are so fun. Eternal Wild Fox says, good evening. What's up, Eternal Wild Fox? We just exited Vim. We are now enlightened programmers. Vimy says, at RPWH, or buy a new PC. That's right. You can either hit the exit Vim button on top of your PC, or you can just get a new PC that isn't running Vim yet. And be careful about the commands you run and what you wish for. Vimy says, at Eternal Wild Fox, there he is! The fox, the man, the legend! Eternal Wild Fox. That's such an old video, Vimy. I can't believe you still remember that. I don't remember that part of my life. Eternal Wild Fox says, I'm doing okay. What about you? I'm doing good. I'm having a great time this morning. Thank you for asking, Eternal Wild Fox. I always appreciate that. And I'm glad you're doing okay. Your byte code looks incredible. Let's take a look. Oh my god. Somebody wants it. Waffle and Nick. I'm pretty sure they both have it already. So good. Does Waffle have it? I gotta see. Is Waffle online? Waffle's not online. Waffle's offline. Yeah, Waffle has it. Nick has it. We'll see. Yeah, Nick has it. They both got it. I've been trolled. Nick says, bro, he is too good, to be honest. It's true. It's like, how do you just get all this bytecode working? Also, I like how they like to, like, screw with you. They're like, oh, we'll put a zoom out option, but no zoom in. It's like, oh yeah, great. Thanks. I always want the pictures I'm seeing smaller. Nick says, how does he even make the bytecode? How does he do it? He needs to make a commercial, like, starts in the black and white, and like, do you struggle with making a bytecode? Here's how to make a bytecode in 3 easy steps. Vimy says, he is eternal. Yes, Craigasm. Nick says, yes, I need that, lol. That's right. But look, he's making a bytecode in C#. So a equals 0 if a is greater than 0. He loads something. We set the variable a. We load something. Oh, 0 twice. And then we can, if the get variable of a is greater than jump if not true. Oh, that's beautiful. That's beautiful bytecode. Load 1, print. Load 2, print. Load 3, print. And exit. Ooh, you even have an exit. How professional. How professional. Also, this left operand, is that an index? 1, 2. It is. Very beautiful. Very beautiful. It's not an index, it's a number, isn't it? It's 1, 2, 3, 4, 5, 6, 7. Yeah. 1-based index. Like PHP, baby. It's beautiful, though. Nick says, I need a pyramid scheme for languages and compilers. Well, do I have a deal for you? By donating 2 to the power of however many times you've donated every day for a whole month, that will take you far. And you'll be a ultra Chad mega genius. I promise. It starts at just $2. Or $1 if you start at 0. Nick says, really? No way. I'm signing up. Oh, God. I'll get you in my email list, bro. Eternal Wild Fox says, it is a step number. Nice. So it's like step 1, step 2, step 3. That makes sense that it's not 0-based then. Nick says, yay. Lamau. This bad scammy commercial. We're gonna make a commercial for, like, programmers. A scam commercial. Vimy says, if you don't have a wide taskbar, you can't bytecode this hard. That's incredible. It's true. It's what contributes to his mega genius. See, I'm not a genius. Look at my non-existent taskbar. I I wish I could be a Giga Chad, an enlightened programmer. If only my taskbar was wide. But I would have to pay for Windows to change those settings, so RIP me, I guess. Vimy says, programmers. Shh. The shush emote is so good. Programmers. Shh. I like it. I like it a lot. But yeah, so this is now valid code. And it's terrible because we have a variable declaration and also a lambda syntax, right? So this is a lambda that returns an integer, takes no parameters, and it returns the integer 420. This is its body. So this is now a lambda, or a function, that can be assigned to a variable. So now you just take this and put an equal sign in between. This is the expression, this is the declaration, and you see the crossroads we're at. So at some point in the parser, we need to simplify this where we can detect a lambda expression directly after of the beginnings of a variable declaration. I'm not sure how we're going to do that. It's basically like if we get a function type, look ahead for this, and then just parse a function body into what we've been doing, but we also have to create this type for the function, so we're going to have to like save the actual this part, right? And put the there's a lot. That's why that hasn't been done yet. Vimy says, Nick says downward funarg with terrible syntax, lol. That's correct. It's not terrible syntax, it's just simple syntax. How about that? Simple syntax. I'm just a simple programmer. I like a simple syntax. Vme says, become a programmer just for $49.99 and get 5 bro codes for every programmer you bring. Also, I'm gonna hear my own voice in like some scam commercial now. Nick says, lol. I like the programmer class. How to become a programmer. Okay, so downwards funarg, we're trying to pass this function, which returns 69, to this function, which takes in a function, which returns an integer. Luckily, 69 is just that. In any case, we assign it to a lambda, which is also the same signature, so that the expression, the reassignment, type checks correctly. Because now, if we had another signature in here, I don't think we need a comma, then we can do something like this. If we just had another integer, it's going to be like, hey, you screwed up. Well, that's an interesting one. I am curious about that. And it's a curiosity that perplexes perplexes even the GigaChad programmers of our time. It seems that multiple arguments cause an infinite loop. So let's just fix some issues. Did you see, what did I just type? I typed like a caret at character. What am I pressing? I don't even know. I'm gonna like close Emacs on accident, but Lambda XT, what's going on? How's it going? It's great to see you again. Thank you for tuning in. What if I didn't watch the stream? Oh no. You can listen. So there's an infinite loop, sadly. How is there an infinite loop? It doesn't even make sense. Okay, lambda body. Where's lambda body? It's here. We create the next expression, and then we do the thing. We parse into the next expression. So lambda parameters is what we're parsing, and we gotten into an infinite loop somehow. Lambda XT says, C doesn't make sense, and that's why you should exclusively code in Lua on the JVM. Oh my god, no. Vme says, at Lambda XT, there he is! Our OG Landar! Ayo! What emote is that? Hype mine. Is that a dog smoking a cigar? That's pretty dope. That's pretty dope. Vme always gotta flex with the premium emotes. They're beautiful though, and they're amazing. Oh, I forgot when my... Okay. I'm gonna just do this. Oh, damn. How does dust accrue so fast? And I can't even see it. Okay, I'm doing better now. C doesn't make sense. I would agree with you. So we have an infinite loop. And that don't make sense. So let's think about how this could go wrong. Lender XT says, what would you say if I told you the compiler wasn't fun? I would show you a meme of that, like, you know Gus from Breaking Bad? I would show you him, like, straightening his tie. You know that meme? And I would have the caption say, you write programs for fun. I write programs because I am a program. We are not the same. Okay. That's my response, Lander. That is my response. What is your response, sir? Vme says, Lander XT, Lua running from Python interpreter that stands on JVM in a Docker container in a VM in Proxmox. Oh my god, no. Why? Why are you torturing me with these ideas? LanderXT says, I am doing that. Vimy says, you code for fun. I code because I am a masochist. That's right. I just like to torture myself. And I actually lost my balls in an accident. So turns out I gotta use programming. The ladies in high heels aren't gonna cut it. Sadly. I'm so ridiculous. So is it with our parse type? What's our issue? What's our little tissue issue? Okay, so when we're parsing lambda parameters, we have node add child lambda parameters. I still don't know how we're printing a node out forever. We're setting next child to the wrong thing. So stack result is first parameter. Vimy says extreme deballization by Java debugger. Now that's a title. Now that's something I can get behind. Lamau. So when there's a lambda parameter, which in case you haven't figured it out, it's a lambda parameter. Then we print, say, hey, we found the print node. Hi, did you hear that? I don't know what I said. Hey, we found it. LanderXT says code in PHP on the JVM, but only accessible through the Python interpreter running on top of the common language runtime. Oh no. Why do you do these things? So how do we end up in lambda parameters forever? We shouldn't end up in there forever. Also, this is a little confusing. When did that happen? So the current stack result is the last expression. So we set the next child to the next expression. We set the result to the next expression. This is what we do everywhere, and we don't get infinite loops. So I have a feeling it's not this. How do we get an infinite loop here? So maybe when we stop, we don't do the right thing. See, if we get to here, then our stack operator should be different, and we shouldn't be able to infinite loop here. This sure is confusing, and we definitely handled the error of any stack operator. Hey look, it does an infinite loop. What did I fix? Wait, did I thought I didn't change anything. Oh, I removed it. I was like, wait, what did I do? It just says symbol integer a bunch, which is interesting. Oh man. Vimy, I'm not going to read that, but that's amazing. Just a tiny bit, just a tiny bit. So if we have no comma, I'm pretty sure we did a test. It doesn't matter either way. But if we go to the top, we can see that we're actually getting through parsing. We generate an AST, and then we have an error, it looks like. So the type, oh boy, time to kill. Kill it. So the type of this is like incorrect or whatever. So confusingly, so let's just look for stack. I think result. Yeah, like that. Okay. So that doesn't get us the proper thing. I need to do dot star. There we go. So now, Vimy says, program is not hanging. It's planned infinite loop in progress. That's right. That's right. We're just using the infinite loop as a way to show our progress on the program. Yeah, it's just a demonstration for the stream. It's totally planned. Everything's cool. LanderXT says the YouTube VOD needs to know. Nah, it's our special knowledge. It'll be our little secret. Why happen and how happen? What happened and why? So these all look the same to me. It seems like next child gets sets. Yeah, so next child I still can't speak, gets set to the next expression. That's a lot of hard words with S's and X's. And not one of them is the fun one. VMe says program is not oh, I already read that. This is how great of a morning I'm having. I forget. So we set next child the next expression, working result for that, and then stack handled parse as our status. And that's what we do right here in Lambda parameters. So that's interesting. All we want to do is advance the lexer, which is what expect will do if it's there. So VMe says it's by design. VMe, the loop is not infinite. Control C is just the intended way to break. That's right, it's just compiling and it's not done. No, but there seems to be a type error, which would make sense. So maybe it's in the type checker. When there's a type error in a function. Oh God. So for each parameter, I look it up in the context to make sure that it's a variable declaration. And then I add the type that it is into the result type. Okay. So there's nowhere we're calling type check expression without error behind it, right? Error equals, and there's always an if error.type return error. Yes. Yes. Yeah, so we handle the error literally everywhere. Vimi says, just add in memory SQLite database and use it for tokens/other lookups. Oh, that's actually a great idea. Have like a communal language where the syntax is defined by a database that anyone can change, like Wikipedia. So you could just have the language, anybody could update it at any time, and then the language makes requests to actually do that, like do lookups of what keywords are based on token type. That would be awesome. So as far as parameters, we're getting... Excuse me, that was disgusting. Which error are we getting? We have left-hand side type, right-hand side type, and expression. I think we can work with that. It looks like this is happening. But the right-hand side return value is returning an infinite loop. So the return value of the right-hand side, oh boy, is going to be a function. Okay. So we know it's a function, and it's the return type of the function. Hello? Is it result type? What did I call it? The result type, it is. So you can see that we have a symbol function, and that's our result type. The children, the child, is a new node. And okay, this is confusing. Vimi says, who needs error codes? I just exist with one. No one will notice, Kappa. Lamau. Mimi, you are so creative. It's amazing. You make me laugh. So, function, child, next child, children. And then we get it in the thing. And so this is making an infinite loop. Parameter, add child, result type, parameter type. Oh, okay. Well, yep. Yeah. So, in case you don't know, and you're not familiar with our code base, node add child lets you know parent is modified, new child, of course. New child pointer is used verbatim. So this new child pointer that we allocate once outside of the loop is used over and over in the loop to just continually add the same child to the result. We should probably have protection against this. So let's take a look at node add child. We really got to separate some of these things. So when we're adding a child, we add it to the end, I'm pretty sure. Because we say if children exist, get the last child and then set next child. So for every single child, I would like to say if child equals new child, then printf warning, refusal to make circular, so this is a developer error. Developer warning, sure. Refusal to make circular linked list in node add child. I think that's good enough for now. Here, we'll make some people happy and do this. Look at us. We're professionals now. And we're just going to return right away, because we don't need to deal with that. Look at us. So now, hopefully, well, it didn't work, but hopefully it did. It still didn't work. I wonder why that is. Child is the node pointer. Also, Control-G no longer gets rid of my region. I can't okay, there we go. It just had to get big enough. Yeah, it just doesn't work now. Yeah, so Control-G normally unselects things and quits. It does not do that. Okay, so it seems that the infinite looping, I didn't kill it and I just switched buffers out of habit, and it was just running in the background, kind of slowing Emacs down. So, Lamau, fix that. Vimy says, live, laugh, sig term. Isn't that beautiful? Okay, so I still don't get how this doesn't catch anything. Because you'd think we'd go, oh, that's not allowed. Child, if it's equal to new child, no. And then eventually, see, we never check the last child. Is that what's happening? So how do we check the last child as well as the first? We have to do that. This will check the first, and this will check the last. This could probably be solved with a do while, couldn't it? Hey, look. Look, Mom. It worked. Cool. I guess. So, why do we have to duplicate this code? Let's think about this. So we have a child here, and we're going to iterate, and we change it every time. So we need to check before we change it, but we also have to check after. So this one could actually go here or here, which is actually really interesting. This could just move down here, and everything works the same. That's a weird control flow, huh? So if we did a do while, what could we do? We could say do child equals next child, this while, that doesn't really work. So a do while, we'd use while child. I don't know, I think we're just gonna have to live with the duplicate check. I don't really like it. If anybody knows how to solve this, it's probably obvious. I'm just not so smart. Because we could do like this, but then that's not going to give us the right answer. So we'd have to do this. And then we'd have to think about, so when does the check happen? Check would happen still in the same place, you know what I mean? This doesn't really help us. Because this doesn't need to happen once or more times. It needs to happen until. If we had an until, this would be easier. Whatever. Yeah, we're gonna live with the code duplication. Sorry. Okay. So, where were we? What are we doing? We can now no longer make a linked list with node add child. That's a good thing. We're getting mismatched types. Which is exactly what we want because we changed this function signature, this lambda signature, from the variable declaration signature. So now we just need to get rid of this little developer warning. And we're gonna have to just do one of those. That's really confusing. We have parameter underscore type and check parameter dereference type, whatever. And now it works. Look, this is a function which returns an integer and takes in a function which returns an integer as well as an integer. Recursive types. Hallelujah. So if we get rid of this, our type checker will not complain and we will generate our code. So if we take a look at our code, hey look, we have some basic CFI start proc and end proc now. Hilarious. Works for me. So as you can see, we have nested function definitions, which hopefully is fine with CFI start proc and end proc. It's probably not, so we're probably gonna have to only do that on global. So this won't work because we have to only do this on global functions. But it wouldn't be that hard to figure out which code gen context we were within and emit that, whether or not we need to do that. We're just going to say to do CFI function stuff. Woohoo! In any case, where were we? So we have main. Let's open both of these. Perfect. So main is this entire program. And you can see that in the .data section, we have two variables, two global variables, 69 and foo. So these are symbols accessible in the data section of the executable. In main, we do the classic function entrance and make some stack space for ourselves so that we don't have to worry about anything. We can push things that are larger than 8 bytes without really having to worry about it, at least for now. This is also, it crashed without it for some reason, so we're keeping it. You can see that immediately we jump after this function definition. So this is this lambda, and this lambda has to be defined somewhere in the executable, and it's defined right here. And you can see that we use a local label, L0, which is just a compiler-generated label, which is a memory address, right? And then this is a function entrance, just like main. but a nested function entrance, so it has a little bit more of a saving and restoring to do. And you can see it just returns 69 in racks. And again, optimization to be done, very much so. But in main, the execution flow, we'll jump over this to after L0, where we will load the effective address of this lambda.L0, that label, the start of the function. We will load the address into racks. Load the effective address is what this mnemonic stands for. Then we will move racks, the value, into 69. And this is a memory address, so it'll actually write to the RAM in the data section of ELF, and this symbol will be written to. So 69 will now store the function address, the function pointer, to this lambda. Ain't that a beautiful thing? And effectively, that was our first variable reassignment. Then we have another one, which is foo. And you can see foo is, once again, we jump over it. Because this is not a function call, we don't want to execute the body, so we jump right over it. But the function itself makes a function call to int. And the int function is actually passed as a variable. And it's loaded into racks, and then we call indirectly racks. So we just jump to this address that is stored in racks. And hopefully, that's what is passed to it is a valid function. So then we just eat our little push here and restore our variables and return. And you can see we load this lambda address and store it in foo. So that's this lambda right here being stored into this variable declaration. How beautiful. Now we have a function call of foo. So we made it to here. And what happens is we push racks just to save it, because racks is always the return value of a function. We move 69 into racks and push it. So 69 is our function address, and it should have been stored. Everything should be good. So that moves into racks, and then we push that. So when we access 16 off the base pointer up above, int, that should be what we're pushing right here. And then we have the variable access of foo, which moves into racks, and then we call racks. And then clean up the stack before we return to the libc. Okay, does anyone want to try it? If you notice something wrong, hopefully, let me know. If not, we're going to use GNU assembler as to generate an object file, and then we're going to use that object file to generate an executable. And then we're going to run that executable all in one shell command. Oh my. Chat. Oh, we were so close yesterday, but we didn't get it. But this is so good. Chat. Everybody watching. We solved the Downwards Funarg problem with the worst syntax in 2022. Welcome to my stream. We've done it. I'd say we've officially made a compiler. I'd say we've succeeded in the goal. This is really cool, and this is something I've never been able to wrap my head around before. So the fact that we were able to do this is so awesome, and I thank you all so much. We actually did it. We actually solved the Downwards Funarg problem. This is beautiful. Who wants to rewrite some code now? Yeah? How about that? Let's do it. So we no longer do it like this. We do it like this. Also, we are in the wrong mode. And we have to rewrite our Emacs major mode as well. So we've got a little bit of stuff to change. But for now, all this should be the same. Whoops, missed 2 spaces. And then this is going to need to equal a lambda, which also takes no arguments. I think that's pretty good. So now defun can leave, foo can still happen. Okay, now bar is an integer returning, which takes in a pointer to an integer called pointer. And this equals a lambda with this body. Oh god. And all this should be the same. Who wants to... Should I put out a poll to chat? Do you think it's gonna work? I don't think it's gonna work, but we can try. Our downwards funarg problem is now solved, but the classic case in compilers is you solve one problem and you break all the others. So hopefully pointers... Yep, look at us. So we have a variable reassignment of a variable access putter and int 69. So if we take a look, we can see that's actually the dereference of putter, which is interesting that we're no longer catching that, right? Oh boy, back into bug checking, bug handling, bug fixing. That's what it's called. I'm very bad at this. So I think this is actually an issue in parsing, which results in an error in type checking, because the right-hand side type is correct in being an integer, but the left-hand side type is just a variable access. What happened to our dereference? I don't see an entire dereference in this entire syntax tree, which is a problem. So the parser is not generating dereference nodes or whatever. So let's think about why that is. So if we see a valid type, okay, let's think about what happens. So we parse this type from this token. I don't know what this is going to look like. So our token is integer. We get symbol integer. Token is integer. We get symbol integer. Type not found putter. That's perfect. So when we say type not found putter, that means that we're going to go to here. And see, the thing is, we get type found for at. Does at alone produce a valid type? I don't think it should. It should have to be at followed by a type. So at followed by a variable name is not the same thing. Even the regex can tell the difference, you know? So what's going on here? We need the names of the parameters, but we also need the return type of the lambda. How fun. I think we fixed this issue. Yeah, I'm just gonna say check for lambda now. So we parse base type, and if that doesn't work, we get here. So let's just print node here and see what we got. I guess we need symbol node. What do we get? We get literally everything that isn't a lambda, so kind of busy. But we're totally fine here. We're totally fine here. This is exciting. This is amazing. This is one of the best episodes. We're going to make a lot of progress. So a dereference is nowhere to be found. How are we skipping them? So when we parse the base type, I believe that we are modifying non-copies. Is that true? See, we only want to modify these if we actually were able to parse the type. Which wasn't an issue before because we would just return an error. But now we're dealing with the error gracefully in some scenarios. So it gets a little tough to deal with that, right? So the problem is, see, we're using length in Lex Advance. And that's not good. So time to make a bunch of copies. Current copy, which equals current. Size t length copy, which equals length. And char pointer end copy, which equals end. Look at us. Look at us. Look at us. By the way, chat, in case you're here for the first time, we just solved the Downwards Funarg problem, and it was successful. I don't mean to brag, but I am excited about it. Our compiler has now solved the Downwards Funarg problem, so functions can now be passed as arguments to other functions and called, and their results can be returned from this function. Because when we run this program, it returns that good old 69. Look at that. Which is exactly what 69 returns. So foo returning 69 by this function call means that 69 is being returned from foo because it's calling 69 in the name of integer. It's just a variable that's being passed. So cool, so cool. And, you know what I should do? I'm going to rename this file to save it. And this is going to be Downwards Funarg. First ever working solution. Woo! .s. Hello? Did I press enter? I did. Is Emacs done for? Oh, nope. Okay. I'm still here. Oh, I see, I see. See, I always do this. I always assume it's rename the current file, but that's rename buffer. See, I'm not the smartest cheese in the block or whatever. I'm a wedge with a lot of holes in it, like Swiss. I almost wrote cheese. Did you see that? Downwards Funarg problem. First ever solution. We're gonna do it. .s. Hooray! I'm less idiotic now. Okay, let's use these copies. Current copy. Length copy. End copy. Length copy. Where else we at? Where else we at? So current beginning. Current copy beginning. So we use the current copy beginning, the length copy length. Snarlferb says, is there any specific language features you are looking to implement, or is it all kind of design on the fly? It's definitely all sort of design on the fly. But, you know, if you have a suggestion, I'd be down to hear it. For now, we're just running with it. We'd solved the downwards funarg problem. We're going to solve the upwards one eventually using lonely functions that don't access local variables outside their own scope. It's going to be fun. It's going to be fun. But yeah, so I have a vision for the language. It's not like I'm aimless and I'm just wandering around going, what do? I have no clue what to write. You know what I mean? Like I have a direction I'm going in. I just don't have the time to write it down on paper. I just kind of have to do stuff as I can think of it. Because I'm only one person and I'm taking on like a fairly gargantuan task of writing a compiler. At least a compiler of this, like a statically typed, effectively memory safe, nearly memory safe at this point. We only have issues with function type checking lambdas and function variables because we just added that literally last stream, so Lamau. But yeah, we're still very early in the process, but it's all design on the fly. It's just like as I think of it, because I can't really be asked to write it all down. I can be asked, and if you I put that in the wrong spot. And if you want me to, I can write down like a roadmap, but I don't think it's necessary for this one-man goal. If anybody wants to make pull requests, they can absolutely ask and be like, That's what I should work on, because you're not going to be working on it, or you know what I mean? I can communicate if anything like that wants to happen. Also, look at me writing things wrong over and over. So if we do get a valid type and we don't return an error, we should advance the tokens, like our lexing token for the parser, our state. I should have all this in a parser state struct as well. Snarlfurb says, lol all def. I like it. I'm following along. Awesome. I'm glad you are following along. It's I never expected anybody to enjoy hours and hours of really monotonous work. It's just looking at letters on a screen all day. But I'm glad that people enjoy it and they can learn from it. Because I guess that's how I learned off the internet, from people that were doing the same thing as me. So I'm just paying it forward for you. All day, every day. Alrighty, so now we advance the lexer only when we need to, instead of all the time. Hey look, it worked. Also, we now have a lot of debug print. Where did I write that? Oh no, okay, here it is. We found it. Look at us. We gotta figure out, what is type not found? It's the parse get type. Oh, so if we look at something and it's not a type, we would just print right to standard out before, because we go, hey, this is bad, but now it's not so bad. That's kind of expected. Awesome, awesome. So now pointers appear to be working. So let's think about what this pointer example should return. This is a lambda, which returns an integer. What integer? A. A is awesome. It's a variable declared right at the top. And it's 0. So initial dots, it should be 0, because it's not reassigned here. There's no A reassign operator, at least that I see. Yeah, there's literally none. So effectively, it should be 0. Oh, but this is pointer, so we're probably doing like a dereference. Yeah, so we get the address of A into this pointer to an integer, and then we dereference this pointer and write 69 into it. Lamau. Also, are we getting dereference now? We are. Beautiful. Beautiful. So you can see this variable reassignment here. Nope, here. These are the same thing. Because this variable reassignment is a dereference of the variable access putter. Putter is a pointer to an integer. Dereferencing it means we just have an integer, so we can reassign an integer into this variable expression, I guess is what it is. I don't know how to describe what this is, but it does return a value, so it is an expression. It's kind of odd. In any case, we then dereference this putter and write 69. Since it's the address of A, this means that A should be 69. And then we set test putter to B. We make a pointer to a pointer, so putter, and that becomes a pointer to an integer, and we point that pointer to a pointer at pointer, the address of pointer. Then we write, okay, I get it. So we dereference the pointer as test pointer, so now B should be written into pointer, because pointer points to pointer, and we assigned test pointer to pointers. Now pointer does no longer point to the address of A, it points to B. That was a lot. I said pointer about 40 times. And then we dereference the pointer and write 42, so that means B will be 42 once again. So that's probably just to distinguish that it's not what it was before. Like the pointer doesn't dereference A and overwrite 69. So we should return 69. What does this return? We return number. And number is... Okay, see, I get it. So number, this is bar. Bar takes in a pointer to an integer. and it dereferences that pointer and writes 69 to it. Legendary. Legendary. So we write 69 to any number we pass in, but it has to be a pointer so we can update it where it exists, where it has been created. So we create number, we create a pointer to number, we call bar on numpointer and return number. So we should return 69, whether or not we do all this bar stuff. So let's ensure that with the bar stuff, we can recompile it, go to code.s, and we can run our little magic incantation. And look at that. Look at that. That's a 69 right there. 69 right there. Okay, so now let's check if foo returns 69 as well, our pointer thing. So pointers as arguments works, but what about pointer local variables? Hey, 69. And let's, just because they both return the same number, that's a little sketchy, let's return like 120. Just to be clear. And look at that. Failed with code 120. Isn't that beautiful? Look at all this assembly. It's beautiful. So our pointers example still works. Or now works, I should say, in this new form. And we did have to make a change to the parser, so I'm pretty sure it was a good test to do. So now pointers has been rewritten. What else did we have? Factorial. It's definitely not going to work anymore. So factorial is now an integer returning function that takes in an integer. So I need to do my little poink. And then we can just steal this for here. And everything should be the same. Ooh, Eternal Wild Fox says, I'm solving bugs in optimization of the code. I hope I get the interpreter done today with the if and while. That is so much. Didn't you start... Wait, didn't you start the interpreter today? That was at 4 a.m. today. Time to build the runtime to execute the generated bytecode. That's an interpreter. My guy, you're gonna finish an entire interpreter in one day? Bytecode interpreter? That's incredible. You work so fast, Eternal Wild Fox. You are truthfully eternal. Eternal! Alright, so now let's go to code.s. I guess I gotta recompile into factorial. Could not get local base pointer offset of variable fact. Huh. So during code gen, we could not get local base pointer offset of variable. Yeah. Variable fact. So we're looking in only in our current locals because of our little dilemma here. Okay. Let's do some git to commit, just so we don't make too much of a mess. And let's rename some things in the examples folder. So I'd like to rename a file, the downwards funarg, and we're going to name it downwards funarg original. So now we have downwards. That's not what I wanted. Where's... I renamed the wrong one. Isn't that amazing? So I get to rename the file again. And then I get to rename the file again. We'll get there, folks, I promise. Hey, look. So here's the original downwards funarg, where we tried to like figure things out and slowly, incrementally parsed more and more at a time until we could handle it all. And here is the actual example I would like to have as downwards funarg. Okay. Perfect. So now I can commit this as an example without feeling horrible about myself. We can also update pointers and factorial, but we're going to save that for another commit. Why not get rid of an empty line? We don't need it. Comment. Yep, definitely doesn't have to be multiple lines there. We don't need an extra line. We don't need that to do, but we do need this fix, which is instrumental in our code gen. We'll do our if child, like prevent duplicate children from being added. We'll comment out type not found, so it's not spamming all the time like it was. We'll get rid of the extra print node and lambda parameters. I can't believe we committed something like as egregious as this. This is horrible. In any case, we fix it and move on. Pretend it doesn't happen. We use the proper values here, so that's good. Let's make sure, I guess that is everything in a base type. So we're all good there. Base type is good. Yep, base type is good. Yep, that's an old to-do. And those are just a little bit of a comment fix and syntax. Alrighty, and that's just a comment. And in type check expression, we have to allocate a new node for each parameter type so that we don't just keep using the same node as a child. Look at us. And we're going to do a celebration commit. Downwards, funarg, solve. Woohoo! We can now pass argument functions as arguments to other functions. This is possible due to functions being treated as variables instead of a separate set A rate. Yeah, a separate entity. Woohoo! Just gonna give it a woohoo and a happy face, and we're gonna get out of here. We did it. We commit, and right away we're gonna push it. We are confident. Alrighty, so what other, I think we have more example to do, which is why I didn't commit. So we don't use defun anymore. So we have GCD Euclid, which is an integer returning function, which has two arguments, A and B, which are both integers. This is the body. Oops. This is the, oh my goodness. This is the body. We'll get there. And that should be that. We still get fact in fact. Okay, that's right. We didn't solve our code gen mystery. So here's the thing. We're trying to get an offset from this register. So we're going to use result. Because I don't think we're using result here. I don't see result. We have result register of the expression, but the result string isn't used. So we're going to have it equal RBP. And this is going to be %s. And this is going to be result. Result stores, I don't know. I guess we could put this here. Result stores offset calculation. I don't know. Or register. Sure. Sure. So why did we do this? We did this because we want to load a new value into a scratch register if we don't get it here. Something like all of this. Okay, so the idea is if we don't get it, instead of just giving up and returning an error, we say, okay, this is not a local variable, it's a local variable that is out of my hands, because it's not a global variable. If it's a global variable, we just handle it here. So this is a local variable from a parent environment. like factorial. See, fact should be a global variable, so that's a little sus. You know what I mean? So why are we trying to get fact as a local variable? We're trying to get fact as a local variable because we're in a local context. See, just because we're in a local context doesn't mean that we're accessing a variable from that context. So we're going to have to find the context that actually our variable resides in, like this. Okay. Okay. Find environment that local variable resides in. We're going to say context. Find context that local variable resides in. This will determine how it is accessed. Okay, so we're going to have some parsing. Well, I guess it could be a codegen context is what we need. We need a codegen context, and this is going to be our variable residency. This is where the variable lives. I know that's weird, but I don't know how else to say this. A variable residency. And we'll just check our context first. And then we'll say, do a thing like this. And say, if environment get by symbol, here, I'm not going to, did I copy and paste? I did copy and paste, so this is good. I didn't want to get rid of the working code down here. So the idea is this needs a while, and we're going to say while, I don't even know, while codegen context parent, and if we get to the end and parent is null, that means it is absolutely a global variable. So we're going to check our variable residency. And if we don't get it, we're going to say our variable residency is equal to the parent variable residency. So we're going to look through all the contexts until we find one, in which case we'll break. And now variable residency will contain the proper residency of the variable, if it's global or local. And if it's local, we want to try. Hey, anybody looking for a code 5? I got one right here, hot and ready. God dang. I've been streaming almost an hour and a half now. I would just like to thank everybody for watching, and also check out the YouTube down below, the Discord. We have a ton of fun on the Discord. We do code review. We can share your progress. Be me with the horrible the horrible nightmares. But yeah, it's a ton of fun. You can share your progress on stuff you're working on, get help, whatever you'd like, and get announcements every time I go live. So how about that? How about that? Alrighty. Back to coding with that wonderful code 5. Access denied in Windows. Okay, so result is definitely not a null pointer. Did we free a null pointer? We don't free result, do we? We do not. We free temp node. That's it, though. So how did this go horribly wrong? Does anybody know? So what are we accessing that we shouldn't? Expression value symbol is fine. Temp node is fine. So we're getting the variable type through into temp node, but we don't actually use it. We're just trying to figure out where it is. I see, but this isn't the type. This is the code gen context. So we're actually looking for our offset. See, I don't think we have to do this anymore. Maybe that's our little issue. That's definitely not our issue. Just going to separate that. So temp node value integer, expression, result, register, and result. Result seems like it shouldn't have changed anything. We can of course change it. So it's not result going wrong. Result is fine. So it could be temp node value integer. Temp node value integer. So temp node. So let's print out the node. I guess this won't really help. Because of that. So if we exit here, maybe we'll be able to see some output. Int 16. Huh. What? No, that makes sense. So our cogen context stores offsets from the base pointer, and our offset from the base pointer is 16 bytes for this variable, because I'm assuming it's the variable fact. See, that doesn't make any sense to me. So we have a variable declaration fact at the top level, and it's becoming a local. I'm a little confused. So let's look at a variable declaration and see what's happening. Is it? That's a complicated one. Binary operator? No. That's math. Where are we at? We have function. What were we talking about? Variable. Declaration. There we go. Jeez. And effectively we say for a variable declaration, if not parent, break. So factorial should not be here. And if we look at the generated code, we should see that factorial is indeed not here. It is a global variable. So why does it think it's local? I don't know. So what we're going to do, we're going to leave this here, and we're going to use, guess what? A debugger that we don't want to use. Mainly just because debugging with MinGW is not the best on Windows. I mean, it's fine. It's just fine. There's nothing wrong with it. It's just that it doesn't give exceptions. Sorry, it's just going through my file system. Didn't want to dox myself. But we will get right to it. So we are trying to compile the factorial example and failing miserably. So let's make sure we do that. Oh yeah. Build succeeded. Hey, look. It did its whole thing. Did it really? Do I still have an exit in here somewhere? I must. Yay, there it is. There's that code 5 we were looking for. Perfect. Variable residency was null pointer. Interesting. That shouldn't be a do while. It should be a while. Because we need variable residency to stick around. Hey, look, that was it. Cool. Thanks, Visual Studio. Sorry that I hate you. So let's think about this. Now, what do we have? we should have a call. Perfect. Look at this. So now when we call factorial, it looks like this. And that is perfectly fine. Obviously, there is optimizations to be done in the future in this code. This is not optimal code by any means. This is working code, is how I'll put it. Not working code, I should say. There's 2 percentage signs. Oh yeah, because we needed 2 percentage signs for the format, but now we're just writing the string itself, so it doesn't really matter. And also, we're still going to have to deal with this. So we still have a to-do here. For each context change upwards, basically equal parent. Right? This is so hard to say. So for each context change upwards, so where we say cogen context, our variable residency goes up 1, we should emit a call if it's local, right? We should emit a call to load RBP from RBP. Yeah, so we have to load our base pointer. So we have to emit a call to load the base pointer of the parent function, because we allow for nested functions. Sorry to say. So basically, if we have a context, we have to load BP each time, but only for each function context, though. Because an if context exists, but it doesn't create a new base pointer. This is where cogen context and... So this is where scope and context kind of diverge, isn't it? So for each scope change upwards, for each context change upwards, base pointer load, emit a call to load caller base pointer from our current RBP into some register, and use that register as offset for eventual thing, for memory access. So the idea is, if we have a function within a function, we have to access the parent function's locals and then access from there, which means we're going to have to do some calculations based on the actual numbers, or we're just going to have to do some more calculations during runtime and load base pointer from base pointer over and over. Because at the beginning of a function, we push the base pointer and then move the stack pointer into the base pointer, which effectively means the base pointer now is for this function. This is a stack frame. So what happens is you can access the base pointer, and right at it is the actual old base pointer. So then you can use this base pointer when you return from the function just before to pop into the base pointer the value, the stack address here, as long as stack pointer returns to base pointer, right? So the idea is you save the base pointer. Every function does, and then it uses it for itself. So if you have a nested function, the base pointer is going to be overwritten, and the base pointer offset is going to be from this stack frame and not from the other stack frame. So, oh boy. This will require us to differentiate scopes from contexts / stack frame. We'll say scopes from stack frames, which is a problem for another time. Good luck, future me. I'm going to read this and hate myself in the future, I can almost guarantee. In any case, I'm going to get rid of all this stuff. And get rid of this because we don't actually do it yet. So might as well just have it here. And then we can just do this. So overall, it's a simplification, but it does work. And I think this that's kind of important. Yeah, I'll just leave them on new lines. So if it's a global variable, just load the symbol address, and if it's not, load the local offset. And if we never break, we'll be in the global. See, I think I should just do this. And I can say if not variable residency, return error, and we'll do an error prep. Wow, I've been coding for a long time. And this is going to be an error of, I don't even know. And this is going to be could not find variable declared in parent context. And we'll do a printf of our variable, which is what? What is our variable? This is a variable access, so it's just expression value symbol. We'll put it in quotes on its own line. And we broke it again, hooray. So, interestingly enough, we say, look for this, but then variable residency, see if we break, it should work. So are we never breaking? See, we're breaking. So did I just undo a change? What did I do? I just added an error check for variable residency being null after changing this from like that. So obviously this works, and the code it generates, hopefully, is not insane. This all looks fine in the recursive call. All looks fine. So everything's being generated correctly like this, and let's think about why. Because the global context has no locals. So if it's not, okay, so basically we should say if not variable, well, here's the thing. Sorry, I'm going back and forth a lot. So this context that we get, it can at most be a global context. So we don't want it going past and being null, because if it's null, that just means it's the global context and it doesn't really matter. That's what this check is. So I guess you could argue that this is slightly more efficient and we don't need to error because it's a global variable. The only error would happen if this global variable actually wasn't a global variable, but that's not how things work, so I think we're good. There we go. So basically, if you get all the way to null, that means you're in the global context and it's a global variable. Otherwise, it's a local and try and access it, and we have some stuff to do in the future to deal with that. I should look at how, there's no other languages that have nested functions that I can look at for an example of how they do this stack frame crawling. So I think I'm just going to do the stack frame crawling idea. That's all I got. If any of you have better ideas, let me know. Let me know for sure. So what have we changed? We changed the factorial example into working, and that required some other changes. We changed the greatest common denominator, but I don't think we ever tested it. I don't know if we ever tested this. Failed with code 120. If you don't know, that's the factorial of 5. The factorial of 4 should be like 24. And so if we recompile and run this, there we go. Factorial of 5, factorial of 4, 24, factorial of 5, 120. Beautiful stuff. So yeah, that's good. And we need now greatest common denominator. Let's just test this, so we need to go to code.s and rewrite our little compile command. Invalid syntax. I can't speak. Invalid syntax unknown symbol. Ah, you see what I did? I did our eventual syntax. That this will work eventually. This is how it will look. For now, this is how it will look. Not so great. It's fine though. We'll deal with it. There we go. Now it works. And this should return 8. That's the greatest common denominator between those two. And if we take a look, failed with code 8. So let's modify our program and get the greatest common denominator of 80 and 32, which is 16. So we need to recompile. And there you go. Failed with code 16. We are now getting greatest common denominator in our own programming language with our own functions, if-else statements, etc. And recursion. Isn't that beautiful? We should try and do a continuation passing style. Can we? Oh no, we can do tail call recursion in this. Tail call recursion is going to be tricky because if is technically an expression. So we can only do tail call recursion if both branches of an if have the same function call at the end of it, which is actually going to be pretty dope optimization because that's going to remove all of this and that's going to be clean. It's going to be nice. Woot! We have changed all our examples into working form. So let's make sure we get those committed. And say update examples to I don't know, to actually work now. So we don't need the comment. We do need that big change in variable accessing. We don't need a to-do comment from me. There we go, that would be it. So this is going to be examples. Rewrite functions in new variable declaration format. Syntax, I'll say. I think that's a good enough message. I don't think we need to expand upon it really, because we didn't change anything. And I'm so confident we're just gonna push it right away. Perfect. Perfect. Okie dokie. We are looking pretty good. We've had a 2-hour stream. I might think about closing up shop soon, but if I have an idea and I start coding, then obviously I'll probably do that. I really, I've been thinking about some OS dev topics that I could cover, and I'm thinking to work on Lenser OS sometime soon on the stream. So stay tuned if you are interested in OS dev. You got stuff coming for you. We should probably do the same thing here with a developer warning. So is this how we did it? We had node add child. And we did if child equals new child, blah, blah, blah. So if parent equals child, blah, blah, blah. Eternal Wild Fox says, nice. Maybe an OS from scratch so we can learn, lol. Yeah, maybe. That's a large undertaking. I don't know if I'm willing to do that. I already made an entire OS. I don't want to make another one. I'll go through the specifics of the low level, but I don't think writing it again would do me any good. I'll just get carpal tunnel. Developer warning. Parse context. Add child. Refusal to make circular linked list by parse context add child. Good enough for me. So now we're gonna have the same issue as before, I think. So we can check after. If we check before, then when we get to the last one, it'll never happen. So if we check before, when we get to the last one, it'll never happen. So let's just keep it consistent and check after. Check our first one as well. You don't need to check after the entire while loop. Perfect. So the inner one checks after the reassignment, and to catch the one parent before this reassignment, this is what that's for. This is why kernel developers use goto, by the way, for situations like this control flow exactly. And it still works. Everything's fine. We just added developer warnings so that we can't create linked lists that are circular in nature. Perfect. Okay, so as a to-do, what have we done? That's right, we have debug information, we have a lot of type checking to do surrounding functions, which we could start to look at. Ooh, we also have to update the major mode, which is quite important, I would say. All right. So our problem is we no longer have defun. I guess that's not a problem. It's a good thing. And function is no longer a type like that. I mean, it's an unusable built-in type. It's kind of a confusing one because we need to know the size of a function during code gen, but we also, well, I guess the size of a function is just a pointer. We don't have pointer here. So how do we deal with that? Let's take a look at code gen and think about that. So equals 8. Look at us. Pointers are 8 bytes always. So temp node is what? Yeah, so temp node is the type. So we can say if temp node pointer in direction does not equal 0, or string compare of temp node value symbol. Yeah, types are always symbols, so then just compare it with the function symbol. So if it's a function, I know there's better ways to do this, I'm sorry. But if it's a function, always just use 8. Otherwise use parse get type. So now in parser, we don't need this function type. Where is it? Default. Here it is. So now we have symbol function type is not found in environment. From where? Let's just check Visual Studio so we can get a call stack. Oh, I'll probably have to do a different one. What are we doing? Greatest common denominator. Hello, Nexovec. Nexovec says, hello, Lens. How's it going, Nexovec? Thank you for tuning in. Did I already press play? Let's play this. Nothing. What's going on here? Exited abnormally with code 3. It makes sense we'd see nothing. So we need to go into code gen. I guess we'll go to parser and put a breakpoint in whatever we just changed. Parse default create. So we removed function from here. So now we're doing some sort of lookup. Okay, so I know what I can do. I can go to main and stop myself here before we return 3. So we say type is not found in environment. So what's our, see, our call stack isn't captured here. So we'd have to go in CodeGen program. So it's somewhere in here, CodeGen program. We're definitely doing x86, so it's somewhere in there. And we're gonna have what? If error.type return error. So let's put that on a new line in CodeGen. That's, or we could check here. We'll think about it. So CodeGenning a program, we'd like to say, if you get here, put in a breakpoint. So any expression in the program that reaches there, interestingly enough, we didn't reach it. We've reached the one in main first. So CodeGen program seems like we're not returning an error from here. So where could we be returning an error from? During generation of global variables? That would make sense. That would make sense. Okay. So the reason this worked before, okay, I get it. I think I know what to do. I'm going to remove this comparison. And I'm even going to remove this comparison. And it's true that pointers are always 8 bytes. We'll get size in bytes from types environment. Yeah, that's close enough. And now in parse get type, we'll have some little checks, some little cheats here. If it's greater than 0, then that means it is a pointer, because it's a pointer in direction. So that would be return 8. But we're going to have to do like make int, right? Something like that. And we're going to have to set result to that. So we're going to say results, what? Type equals integer. Result value integer equals 8. Look at us. Nexovex is working hard. You? Lamau. So after setting result to the integer 8, I don't think we have to do anything else. I think that's it. And we also want to check if id value symbol is function. And if it is, guess what? It's size 8. Let me guess, access, yep, access denied, code 5. Don't that get you excited? I'm gonna drink some water, think about my life choices. That really sucks. That really sucks. So, why? We're just gonna go right to the debugger. We're not even gonna fuss. Okay. Type info children value integer. Why would we use the child? Okay. Everything is fine. So, newsflash. That's all I needed to do. There we go. Now we don't have to worry about it. Parse get type now handle pointers and functions, as they are both memory addresses. This should ideally return format dependent, target format dependent address size. For now, it's a 64-bit language, so it's a 64-bit address size. In any case, function no longer has to be a type in the parser for things to work, which means that function no longer has to be an unmode. Look at us. We have one type again. We gotta add bytes, because as soon as we add a byte type, then we're gonna be able to have like strings, because we can have byte pointers. Then we just have to think about how to operate on pointers. Like, do we want to allow pointer arithmetic, or do we want to be a little more strict and be like, nah, you gotta have specifically strictly declared and sized arrays that you can only access within bounds. Like, do we want memory safety, or do we want to just go all out? I think this is good. We have all of our operators. We have our keywords, binary operators. We got everything. Okay, I think that's pretty good. So we now no longer will highlight. Let's see. There it goes. Defun is no longer highlighted, along with function is no longer a type. Because a function type now looks like this, made up of other types. It's basically a compound type. Isn't that cool? How about that? How about that? So we did it. We solved the downwards function argument problem. That's pretty pog. That's pretty pog. What else did we change? Yeah. So we're gonna actually discard that hunk. And we're going to stage this. We're going to, sure, make parse context add child, not able to add duplicates. We'll remove the function type. And we'll add the handling into parse get type. We'll also remove defun and stuff from the editor mode, but we'll move that into its own commit. We'll do that by itself. So these changes are for no longer having to deal with types specifically in CodeGen. So we'll say function and pointer types now handled in parse get type. This means we don't need them cluttering up our types environment. The user could now define a type, if we ever add this syntax, this ability, to be called function, pointer, etc. How beautiful. We already did it for pointers, but we did it for it all. Isn't that beautiful? So now we would like to change unmode and say editor/emacs update major mode to remove function and defun. Simpler syntax highlighting. Look at that. Would you look at that? Then let's push it. We push right away. Perfect. So now you can go to the GitHub link down below and check out this code. It is all live on GitHub. Okay. So let's go to do. Yeah, we still need to do indenting and stuff. I don't really know how to do that, and I'm, yeah, we can try. So we're gonna try and use Yacht as a comparison, because Yacht has a lot of editor support, in case you didn't know. So if you're curious how to make editor support, check out Yacht. It's a very good language in the Serenity OS project that has lots of things to learn from. So we set the indent line function to indent line. So we need to write a function. Let's just start. Okay. So we would like to write a function called something. And it's going to be, let's say, indent line. Why not? Indent line. And this is what? Indent line function. Set q indent line function. Yacht indent line. Okay. Works for me. Also, we can put a provide here. It's not really needed, but it just means that if we require this file, we'll load this without having to put an auto load. So then we just need to define this function. So we define our indent line as function. What arguments does it take? It takes no functions. It takes no functions. It takes no arguments. Indent a line in the unnamed programming language, lens made for fun. We still got to name it. So they do this little let syntax. Also, look at me writing it wrong twice. They do this little let syntax where they define indent beginning of line predicate, which I'm going to write out just so I don't forget, and then move to end of line. We'll say should move to end of line, and then we save the current point. So I'm pretty sure it has to work like this, but I'm not aware. Thought each of these had to be in their own little pieces. Because then if I go here, yeah. Wait, what? That's what I thought. So this should go to the let. Okay. Just getting confused. All good. So now that we have these variables, we have this let body that we can write here. And in the let body, it looks like we save excursion and then say back to indentation. So what is back to indentation? It's a function found in simple.l, and it's bound at alt-m. So it literally just goes to the beginning of the line after the indentation. That's cool. So I'm going to press alt-m here. And I'm going to press it here, here. Okay, very cool. So we save our excursion. If you don't know, save excursion saves the point and the current buffer. So this basically, this point that we saved, this is going to be saved by this as well. So we save an excursion, and with that, back to indentation. So our point may be here, and when we indent the line, we don't want to move our point, so we save where we're going to start at, but we need to move the cursor to be able to edit the file. So we move it back to the beginning of the indentation. Then what? We set indent to car of syntax PPSS. Okay, I don't know what that means. Parse partial sex state. So parse partial symbolic expression state at position defaulting to point. The returned value is the same as that of parse partial symbolic expression run from point minimum to position, except that values at positions 2 and 6 in the returned list cannot be relied upon. Oh Christ. Okay. So we get some state, which I assume has these, yeah, has those. And we effectively use the first thing from it. So what's the first thing from it? As you can see, we have default values, so maybe it's cell? I don't even know. I wish they would say what this returned. Okay. Looks like they don't ever say what this syntax PPSS does. Ah, here it is. So depth in parens. So however deep we are in parentheses, that is the car of syntax PPSS, I should say. So we're going to set indent to the car of syntax PPSS, which is truthfully the depth in parentheses. Okay, this is making sense. And we set the beginning of line if, yeah, so basically, if we're at the beginning of indentation, then what that will mean is that the predicate should be set to true, but if we're at the beginning of the line or the beginning of the indentation, then this back to indentation will not have moved point. So if our current point is equal to our current point, the one we just moved to, right? So if point is equal to where we came from, our current point is equal to where we started. That means we're at the beginning of the indentation because I pressed Alt-M and didn't move, like me pressing it here. Okay, I'm starting to understand, and that's it. Then we say when. Okay, and when what? When we are both not at the beginning of the line, and char after is equal to a new line. Just char after. Char after that defaults to point. So the character after point, which is going to be this first character. So we're saying when we're not at the beginning of the line, and is that how that works? And then and, we could also use cond, but I guess we couldn't use cond because we need all of them. In any case, we can now have this, yeah, effectively check for the new line. So we're going to say if it is equal. By the way, we use equal because this compares two Lisp objects. So even if they're strings, it'll compare the string that they point to. Whereas using equal is an integer equal. So equal with EQ lets you compare strings and other Lisp objects that are not just integers. So if char after our current point is equal to a new line, then that's a problem. Because this means that this line is empty. So there's nothing to indent. So indent should be 0. Is that correct? Hey, look, I guessed what we should do. I'm not a complete fool. So when beginning of indentation P, so it's kind of weird that we have when not beginning of indentation and when beginning of indentation. Feels like there should be an if here. Okay, we're going to try it. We're going to do a refactor. So we're going to say if beginning... Also, I like how it's boy predicate. It's really funny. I keep reading it like that. So if this boy predicate happens, then we can do this when, right? When beginning of line predicate, set q, move to end of line. What do we call it? Should move to end of line. So if we should move to end of line, let's set that to t if we're at the beginning of the line. Is that making sense? That's making sense. Otherwise, so we have if condition then otherwise. And our otherwise will be when equal char after a new line, set q indent 0. Okay, just checking my parens. So now we basically say if boy predicate, do this. If not boy predicate and this, do this. That's pretty baller. Then we say when we are either, so we can use cond here. So after this if expression, still within the save excursion, then what are we doing? We look for a close paren and say it's indented one less. So this is effectively saying when you are on a line with a closing parenthesis, it should be at the level of its parent versus indented like this. Because Lisp does it the other way. So save excursion actually has its closing paren at the same indent as everything in the body. But what we're about to add, so this says closing parenthesis characters are indented at parent level. Okay. So we're basically going to say when, no, I think we do a cond. What do we do? So if let's look at cond and see what it does. Cond clauses, try each clause until one succeeds. Okay, so we're just looking for one thing that succeeds in all of the conditions that we give it. So if equal char after some character. So we're going to have two of these, and this is going to be closing paren characters. So it's going to be like this. Something like. So now you can see down here, when I execute the current line, it's T, because the char after is a closing brace, but if I'm not on a closing brace, you can see it's nil. So you can see this is working as intended. And then for this when, what would we like to do? We'd like to say set q indent to indent -1. I think we can do like that. Maybe it's 1 minus. Yeah, it's 1 minus. So set q indent to indent -1. Do we have to handle 0? I don't think we do. Yeah, we just say 1 minus indent. Then we say delete region, line beginning position to point. So what this does is gets rid of the existing indentation. Get rid of existing indentation, if any. So we need to delete region from the beginning of the line to point. Not up to point, but up to point. Our current point. Yep. And then we just need to indent to, which will generate, or it'll insert our indent. and we just need to multiply our indent level by our amount of spaces. So now we can have a little def custom. I don't remember def custom, but I know I need it. So def custom declares a symbol. So this is going to be unmode, and we'll just say indent multiplier, modifier. Indent amount, why not? The standard amount will be 2, because why not? And then we'll have a doc string, the amount of characters that the unnamed language source code will be indented. So the amount of characters that each level of parenthesis nesting in the unnamed language source code will be indented. That's a little wordy, but it's fine. And then we have args. Do we need any of these? We should put it in a group, should we not? So let's do group unmode for now. Can I do that to all of these, actually? I guess that's an internal var. We don't really need to deal with that. Okay. Let's load this file and see symbols variable is void unmode. So I need to quote it. Still symbols value as variable is void unmode. Is it this line at all? That's the wrong thing. It is not this line. So we have unmode not existing somewhere. Probably in provide. Do we need to quote provide? I don't use provide a lot. It's not provide either. Or we had to do both. It is. We had to probably quote both. Here we go. We did it. We did it, chat. So now, if we go to our wonderfully indented thing and rune it, hopefully we can just select it all and indent it. Symbols value as variable is void equal. Uh-oh. So how do we do that? Equal. So maybe we should do or. You'd think cond would be fine. Maybe cond doesn't return true or false. Maybe that's the issue. I don't even know. I sincerely don't know. Reload this just to make sure it reloads. Reload this. Reload this. Whoop. Yep, I just closed Emacs. I accidentally pressed, I fat fingered it and pressed Control X, Control Z instead of Control X and Control S, and look at us. It's always good to restart your Emacs though, you know? It was totally on purpose and not an accident, so yeah. Also, I didn't close my Emacs entirely. That's why it opened so fast. I just closed my frame. Hooray. Oh, it worked. Did you see that, chat? It's not working. The multiply isn't working, but oh my god, chat. We just automatically indented all of this. Oh. I would love to be able to go through and add new lines where they're meant to be as well, but I know that's a lot. Indent to proper amount based on customizable value. Look at us. Reload the file, reload unmode, and hopefully, there we go. We now have automatic indenting within Emacs of our beautiful, beautiful language. And I feel like we can add something to it. Where it yes equals this. we should check like if the last line ends in an equals, that's an open paren. We'd have to add one to syntax PPS. Nexovex says, doesn't a part of your soul perish when you write a Lisp program? I actually really enjoy it. I really like Lisp. It doesn't. The only difference is that the parentheses are on the other side, if you look at that, by the way. And the reverse Polish notation of math, but that's just because Lisp doesn't have math embedded. It uses built-ins, which are just functions you can call, which do math on things. Nexovex says, JK, I just don't understand a thing. Lol. It's okay. Basics of Lisp are, instead of calling a function like this, if you had foo, and it took like an integer 25, you would call it like this, foo25. So you see how this left parenthesis just moves to the left of here, and then they're all white space delimited tokens. And then this function returns another value, and here's the kicker, this parenthesized list is actually the same type of object it returns. There's only one type of object in Lisp, a dynamic type. So you can say, okay, this will return some object, whatever foo returns, right? And then whatever foo returns, you could use that as an argument to another variable or to another function. Or you could say, use a built-in like car, which is funny, but it just stands for contents of the address register. And the car just stands for the left side, which you can read in the eLisp manual if you are a wordy person. So you can see a cont cell. This is perfect. So a list of 3 elements, you can see, is like this. You can have a list of no elements. You can have a list of 1 element, which is a list of 3 elements, right? So you can have lists within lists. And this is all done with a recursive pair, which they call a const. And you can see they even have these nice little box diagrams where each pair has a left side and a right side, or a car and a cooter, the contents of the address register and the contents of the destination register. Nexovex says, I get that, and then that's nested. Exactly. Axay says, Lisp is a religion, you blasphemer. Lamau. It's true. But these box diagrams helped me a lot. Like, oh, so the left side can have its own pair that can be a right side. And then, okay, so then this box can point to another box and etc. And once I saw this, I understood what Lisp is. I was like, oh, this is Lisp as a data structure. I get it now. So this little list could turn into this list here. It's so beautiful. I love their diagrams in their manual. They really hide things, but it's fine. There's also dotted pair notation, where the right side of a pair has a dot, and the left side from the left side of a pair, like that's the separator. So left side is 1, right side is a list, and the left side is 2, the right side is a list, and the left side is 3, and the right side is nothing, which means that's a list, 1, 2, 3. Very cool. But yeah, it's basically just one data type that you use for literally everything, and it's dynamically typed like Python, so you can do some horrid stuff if you really want. But overall, I think it's not too bad. It's a little confusing, like you have to use let to create variables, but it makes sense. Why not just create a variable with let and then have it only accessible in a scope? There's no reason that you should have variables accessible in the scope they're created within. Nexovex says, I really need to write a language. I want C, but not for old people. Well, that's called C, because C is not made for old people. Nexovex says, might write a Lisp first, maybe. That's a great idea. If you check out the VOD, the most recent VOD, it's from yesterday's stream, there's a link in the description of that YouTube video, and it actually links to the place where I learned how to write my own Lisp for my text editor, which has an embedded Lisp runtime within it, much like Emacs. But I would say that's a great idea. I learned so much about language design, and like it all clicked once I finally wrote a Lisp. And the tutorial I followed didn't overcomplicate anything. They give examples, full code is available on GitHub, stuff like that. So I felt really open and good about learning from it. So I think we should comment this out a little bit more. So move point backwards to beginning of indentation, to end of indentation, if any. Use the syntax, partial parsing syntax state or whatever to get parenthesis nesting level. This value is calculated using data from the syntax table above. Perfect. So we have to save our excursion, then set these variables, which is why we can't set these in the let. Unless we could save excursion of the whole thing. Okay, it's happening. See, but we have to let point equal to point first. So we'd have to do, yeah, it doesn't work. I see why they did it like that. I get it now. Okay, then we're gonna say, also, did we ever handle if that, we didn't move to the end of the line. Why is this a thing? Move end of line. I'm not sure why this is the thing, but we'll do it just in case. So we have a let with a save excursion, and outside the save excursion, we're going to say when should move EOL, then move end of line. Nexovex says, ooh, I missed one. Snarlferb says, I've been into Ruby. I don't know why, but it's interesting. I really like how you write language, Snarlferb. Like, your written language is beautiful. I can hear it. You have a voice. It's very cool. Nexovex says equals C with stuff like nested comments, generics, modules, using, defer, and so on. Also needs to have full interop with C. Lamau. Have you ever heard of like video game development and the term feature creep? I would worry about feature creep is something I would worry about. Try and keep your goal small, something achievable and realistic. Because it's kind of hard to do all of that as one person. Snarlferb says, Lolo, I feel that way with you. Your speaking voice is so comprehensive. Thank you. Thank you. I really appreciate that. I've always put time into explanatory language versus narrative language. So I'm not good at telling stories, but I can sure tell you the facts. So this is saying, if we're at the beginning of line, if we began at the beginning of the line after indentation, right? We need to move after inserted indentation. We need to move point to after inserted indentation. Perfect. Then we can say not at beginning of line, but at end of line, do not indent. Yeah, so if not at beginning of indentation, but add a new line, do not indent at all. I think that may be a misleading comment. So fix me. Is this misleading? Just gonna slap that in there. Okay, these are our closing characters. Thank you so much, Snarlfurb, though. I really appreciate that. I feel all warm inside. Next of X is feature creep is when you add more features while writing the thing, not what I'm doing here, lol. And besides, that's almost a complete list. Feature creep is just that your game just slowly becomes larger and larger and larger. It's like your language. It's like, ooh, we should have generics, and ooh, we should have arrays, and ooh, we should have modules, ooh, we should have using, and ooh, we should have guards and defer, and oh, we should have exceptions, and oh, we should have full interop with C. And it's just like trying to get all of that stuff done is just gonna be paralyzing, or at least it would for me. I'm not saying you can't do it. I'm just saying that for me, I would get intimidated by my own idea, and I'd be too scared to actually like start because I would be scared that I couldn't finish, if that makes sense. But overall, that's a very awesome idea. Like if that language existed, it would be amazing. It'd be very cool to see. But and maybe the journey of doing it is the funnest part, right? Maybe that's the best part. So maybe it doesn't matter if you complete it. But in my head, I have such, I like build up things way too much. Like they're much of a bigger deal than they really could or should be. So it's hard for me to like give up on something, even though it doesn't matter. In any case, we have wrote an indent function, and we now have automatic indenting of all our source code in Emacs. Isn't that beautiful? I'm also curious, though. I'm not going to do it today, but we are going to take a look. What is some other editors we could support? Anybody use Vim here? We got VMe. He was in here earlier. I bet you he used Vim. So what does this look like? Looks like we have all sorts of different files for different things, folders I should say. So let's look at yoc.vim, which is syntax highlighting. So if current syntax already exists, it says, hey, that's no good. We don't want to do that. So they have a little flag. RPWH says NeoVim. Awesome. Does NeoVim accept like base Vim plugins? It is still Vim, right? If we write one for Vim, you'll be able to use it. So we have a list of words. I see. Does regular Vim may not even have plugins? Are these Vim plugins only for NeoVim? RPWH says, I think so. Not totally sure, to be honest. Okay, we can hope. We can hope. So, what? So we call this function with the syntax keywords. And for every list, so that's a list of lists, right? So for every key in keys, so for all of these, execute syntax keyword key join. See, what is execute a string? I'm a little scared. Does anybody know Lua? I don't know Lua, and this scares me. So maybe this just registers these as... So join should probably make either a string or a single list out of this entire value. Yeah, so this accessing the dictionary with the key will get us this value. And this value, it's been so long since I've read Lua. So this value is a list of strings. So we join each of these strings into its, I don't know. Why do we turn a list into a list? I'm not sure. Maybe we join it into a single string. And we execute syntax keyword for key on join of key. Okay. So then we call syntax keyword on all of our keywords. And then we set up our regex. We're going to use Emacs for this, but it looks like there's some... Oh no. What is /v? We're going to have to look up syntax match in NeoVim. Learn Vim script the hard way. Well, that's exactly what I'd like to do. Let's start on chapter 46. That'll make it easier as well. So, syntax match potion? Okay, so potion is the name of the language that they're creating syntax highlighting for. I was like, potion? Are we an alchemist? What? Are we gonna be a producer for MF Doom? On Mad Villainy? In any case, one obvious part of the language that we need to highlight is comments. So comments start with a thing, which is not in is keyword. I'm not sure what that means. You didn't listen to me. Go back and do the damn exercises. This is a great, this is probably a great way to learn Vim script. This is hilarious. I'm not really just throwing useless busy work at you when I write the exercises. What is keyword? Help syn match and help syn priority. So we can open Vim and get some help. Because hash isn't a keyword character, we need to use a regular expression to match it. So is this all things that aren't? Okay. These are all things that aren't up here? Yeah. So all these types are going to be highlighted because they're here. Right? That makes sense. So all these keywords are dealt with. We don't use them again. All these regex is to catch things that aren't keywords, because they create an enum. See, they have enums in Yacht structure, but for the actual declaration, they match the name of the enum itself. Okay, and after structure and after class. This is starting to make sense. We have comment line, a string, character, escape. Then we have highlight default link. Ooh, thank you for the follow, Smelly Cow. What a great name. Thank you for lurking. Feel free to chat, say hi, and welcome to our Epic Compiler Club, number 109. Then delete function syntax keyword, okay. And let CPO equals CPO save, unlet CPO save. Huh. So there's definitely some things I don't understand, but it also is, I think, totally doable. Looks very similar to Emacs. We create our list of keywords. We have some regex, and then we like register these with the highlight thing. So basically, by saying this is a yacht type, it's saying this is of this type here. And then we can say this type here. Let me guess, yacht type. Yeah, yacht type is actually the type face. Okay, it's now making sense. It's now making sense. Cool. Very dope. Very dope. So this is, we're just going to write a silly little one. We're not really going to go crazy, but why not start it, right? We're going to call it, what, un.vim? I don't really know what to call it. There's no names. So looks like we do something like this and say unnamed language that Lem's created, syntax highlighting in Vim script. And it looked like we had language. We're just going to call it un for now. Unnamed, why not? And then what was it, last revision? It looks important because it's highlighted in blue, so I'm gonna copy it. Latest revision, and this is 2022-09-06. Is that the proper format? Yep, because it's the 6th of the 9th month. Alrighty, do I have no Vim highlighting? Does that exist? What is Vim RC mode? There's no like package help, package learn. I'd have to list packages and go to its GitHub or something. in any case, we're going to start doing this. So if exists, do we have Lua mode? We do have Lua mode, but I don't want to deal with that. Okay, so we're going to do an extra quote so that our quotes don't try and escape themselves. And this is going to be if exists b current syntax. And then we set b current syntax if we are already done. Excuse me. Okay, so now we save something called CPO, right? Oh, sorry. I don't know why we save something called CPO. Or if this is a reference or what. But we'll figure it out eventually. What is CPO? Now we can let all of our unnamed syntax keywords equal a dictionary with, I guess we have to like specifically say each new line is okay, which is kind of annoying. So we have a dictionary of, I'm guessing there's no comma right away, yeah. And this is going to be basically keywords. Can I do that? We're going to go unnamed keywords. And do we do equals? We do a colon, which is mapped to a list of keywords. This is terrible. Okay. So we have a bunch of keywords. And that's going to be if and else currently. Real complicated, I know. I don't think we have anything else really. We have literally none of these. Yeah, that would be it. So that's our keywords. We now have types. And we literally have one. It's integer. So that's professional. There we go. And we also need commas here. Very ugly. Very nice. This is horrible. Yeah, we'll just keep it. That way we can reorder these things. So this is apparently now our keywords list. We have our everything we need, or at least appear to have everything we need. So let's think about what this little syntax keyword does. See, why don't we just say that this dictionary, why don't we just use this dictionary? I'm not sure, but we're going to copy. I know, copy and paste. Big bad. Don't do. Oh, what just happened, by the way? Didn't work. Copy and paste. Hello? There we go. So we're creating a function which takes in a dictionary, and it basically is saying, use this dictionary, join each key that is within it. So for key and keys, so for unnamed keywords and unnamed types, then get the actual value, join them, so get this as a string, I presume. And for some reason there's a space here. I'm not sure why there's a space here, but there is. Probably something to do with execute. And hopefully that would be all we need to deal with things. I think we need to delete the function. And then we can restore our let, and then also let our current syntax equal to unnamed. Perfect. So yeah, now we can let this variable be what we saved, and then we can unlet what is it, CPO save? Do I need to use S? There it is. So we now probably need to do at least some highlight default links. With unnamed keywords or something like that, right? Yeah, also this should probably be unnamed keyword, unnamed type. We're gonna do like that. So unnamed keyword. And I'd like to link this to another one, and it looks like keyword exists already, as well as unnamed type having type. Alrighty, so now that should be our highlight default links, all good to go. And our unnamed keywords will now be syntax highlighted, and hopefully it will work. Does anybody know how to use Vim? You want to test this out for me? I don't actually know. Or just tell me how to use Vim. Can I like run Vim and load this file? Does anybody know? I honestly don't know. I've not used Vim that extensively. But it looks like we've done it all. We still have some regex to do, right? So we're saying that you can find a deck number by looking for this in the displayed text. Or it displays it. Does this set the color that it displays it as? I don't even know. We're going to have to look at syn match help in Vim, I'm sure. But if anybody knows how to use Vim, I would love for you to test this out before I push it into the GitHub. I can send it to you through Discord or anything. So syntax region, yacked comment line, start and end. That's probably a new line. Let's try that as well. We're gonna steal that. Where did he put that? It's above the highlight default links. Syntax match, no, syntax region. And we're gonna get a yacked comment line. So we're gonna have yacked comment line 1 and 2. Can I put numbers in here? Anybody know? We're just using a language that we really don't know how to use. So that's always fun. So one of them's hash and one of them's semicolon. And they should both end in a new line. Generally, dollar is a new line. Like if you go into white space mode in Emacs, you can see each new line gets replaced with a dollar. So I'm assuming that dollar is end of line. That's the same in regular expressions as well. Alrighty. So I guess we will see this yacked comment line be a comment. So we are not yacked, we are unnamed. Something, that's one thing we gotta change. Perfect. And then we should say, so that we still highlight default these things that we create. So we're gonna say highlight default link unnamed comment line 1 comment. This is just our 2 single line comment delimiters. This may change eventually, so we'll see how it goes, but for now, this is how it works. Anyway, again, if anybody knows how to use Vim, please let me know so you can test this out. Or tell me how I can test this out. Like, how work, right? Please don't just open a file called --help. So you can have V mode, you can have X mode, you can have improved X mode. I don't know what those are. Probably extended mode? Easy mode, like evim, modeless. Binary mode, compatible with V. Not fully compatible. Be verbose. I don't see like load script. We have used vimrc, but we still want to load our configuration like normal. We just want to add it to the configuration. Execute command. Source file session after loading the first file. That may be what we need. Well, I don't know. In any case, I think we've made some great progress for today. And I've been streaming for 3 hours, so it is going to be my time to go now. This is a beautiful thing. Beautiful, beautiful thing. I will make sure that I get un mode with indenting all updated and into where we need. So just make a little git commit. Hello? It's not happy. It does not want to commit. I guess I gotta go cd fun compiler. Not aluminium, just the regular one. Yeah, we're still just, nothing's happening. Oh, there we go. We did it. I did it. Hooray. So we're going to say editor Emacs automatic indent support. This is beautiful. No longer must we meticulously is hard to spell. No longer must we meticulously handle white space, white space by hand. Hooray. All right, push those changes to the editor, and we are good to go. So we are all up to date. We can find those updates on GitHub. We'll just go to, Lens Plays Games /fun compiler. Really? Ooh. Interesting. Normally that... I'm not sure why that didn't work. Normally this works. There we go. What did I type wrong? Snarlferb says, sweet! Yay! We got that automatic indent support. We got functions being passed as arguments to other functions. It's pretty dope. It's pretty dope. We got a lot done today. We solved a lot of bugs, and most of all, we just had a great time. We had fun. I really like it, and we'll have to slowly support more and more editors as we go. We are accepting pull requests like we did from our buddy Arnow already, so if you would like to see something done in the language, do it. Come on. I challenge you. No, not really, but in the GitHub link down below, I really recommend you star it, fork it, play with the code, see how it works, change things, use it as a start for your own compiler, do whatever you want. The license is the MIT license, so do whatever you want. Snarlferb says, I like the language too, even in its simplicity. Yay! Thank you. I like the language a lot. I think it's, we'll be able to eventually make it more complex. Actually, very soon we'll be able to make it more complex by having an external keyword allowed before function types. Maybe after. Maybe we'll do something like this here. And an external function will be one that we use as we type check still. We ensure that the signature matches. But you can use external symbols that aren't defined in the language itself. So even though you never assign a function a value, you could say, myPutC, right, is an external function which returns an integer and takes like some char, right, which is an integer. And then you could say, oh yeah, and that's an external function, and then call myPutC and give it an integer, like 40. I think that's a space. And then we will actually be able to do standard I/O. And this is going to happen very soon. All we have to do is add this little external symbol, and then we'll be able to, remember in code.s, when we have our little incantation? So this part of our incantation, the LD part, you can actually link with anything here. So you can link with like MSVCRT, given your compiler knows where to look for it, right? So this is the C runtime on Linux, or on Windows, excuse me. On Linux, you just do it -lc. So once we link with the standard C library, right, it says cannot find -lc because I'm on Windows. I'd have to tell it, hey, it's in C/, I don't even remember. I think it's TDM, and then it's like x86 lib. And then here's MSVCRT. Yeah. So I have to tell it link and then MSVCRT. And you can see everything still works. And when we look at a file of code.exe, you can see it is an executable for MS Windows, but it's actually statically linked with the C runtime, which we could see if we really wanted by doing an object dump. Is it -d or -x? I think it's -x of debug func. No, of code.exe. There it is. And look at all this wonderful, wonderful C runtime stuff that we link with. So then if we link with something from the C runtime, we'll be able to resolve that symbol in the linker, and we'll be able to include its function definition, then just call that external symbol with the exact same name as it has as you provide, right? And there we go. Then we'll have the libc integration. Then all we have to work on is a byte pointer. It's like we can have some byte, which is going to be a byte, a new internal type, which is 0 through 255, right? We're just going to have an unsigned byte character, or type, and this is going to work as our character. So then we can have a byte pointer, and this is going to work as our string type, and we've got plans. We've got plans. It's all happening. I'm very excited, and we're making so much progress so fast. And that would not be possible without all you watching. I do not work on this compiler unless I am streaming. So if I'm not streaming, this compiler gets no work done on it. So the fact that you're watching right now, that means I'm getting work done on this compiler. So thank you. I enjoy all of you for watching so much, and I appreciate it. Because I just feel like a very stupid kid rambling into a microphone about the characters on his screen, right? It's all of you who actually provide the entertainment and make it entertaining. So thank you. I thank you wholeheartedly. In any case, we're now done. We have completed today's stream, so I'm going to do my little ad read, then we're going to get out of here. Check out the Discord down below. It is in the About section. Ooh, we got someone new? No, we just got Tiger. Tiger talking to more people. Good comments. Cartman is, hello. I'm here. But yeah, if you join, everybody waves at you. We love to have new people, and it's a ton of fun. We already have a ton of members, over 50 already, which is mind-boggling. That happens so fast. But thank you to everybody, every single one of these members, online, offline, whatever. You can get announcements every time I go live. You can join a notice group to get pinged every time I go live. Nexovec says good night. Good night, Nexovec. Sleep well. Wait, what? Ooh, this is actually huge. Okay, I'm actually interested. No. Awesome. Are you kidding? There's literally a C manual from Daddy Stallman. Okay, I'm sorry. This is huge news. I'm getting distracted. But we share amazing news like this in the Discord. This is incredible. Explosion. This is incredible. Ooh, boy. Okay. I got stuff to do. But yeah, thank you to everybody so much. Ooh, who else? Waffle Nick, Cartman, and one other. Who? Cartman and King Buns. All right. You get a roll. Everybody gets a roll. Well, not everybody. Everybody that responded. I like how they made Among Us, by the way. It's pretty hilarious. Nick and a Waffle started that originally. So good. And then end with Among Us. Jesus. Anyway, thank you so much, everybody, for watching. Check out the Discord. We have a ton of fun. Announcements when I go live. Code review if you need help. Blah, blah, blah. All my words. Fancy stuff. Be sure to check out the other links down below, which includes my GitHub, where you can find this fun compiler, and also the YouTube, where you can find all of my previous VODs. So all of my previous broadcasts are uploaded on YouTube and ready to view at your leisure. Other than that, there is the PayPal donate button. This is my last little spiel, but down below there's the PayPal donate button, and it is it goes right to me. You don't have to pay Daddy Bezos. You can pay me. Ain't that great? No, only if you want to. If you have the extra money and you feel extra entertained and you're feeling extra generous, that's a lot of extras, then I would greatly appreciate any and all donations that come in, even if they're just $1. It does not matter. Everything makes a difference, especially when all of you do it. Pennies add up, right? Pennies add up. I would like to shout out our most recent donator, RPWH. He's active in the Discord. He's active in chat. He's an amazing viewer, and we love him around here, so give him some love if you do happen to interact with him. RPWH, a legend, a contributor of the stream. Other than that, it is time to say goodbye. Thank you for watching this stream, where we officially got lambdas working in our language, passing around as arguments to other functions. Ooh, pog. How about that? Anyway, thank you so much for watching, and I'll see you next time. Peace. Bye-bye.